Hello guys, this is Wits Lounge, learning made easy, and in today's video we are going to be considering the integrated rate equation for a zero order reaction. Now this integrated rate equation can also be referred to as a kinetic equation. Before we get into the study, it's important you like, share and subscribe. So let's get into it. A zero order reaction is simply a reaction whose concentration does not necessarily affect the rate. So the implication is that if we are to write an equation, A reacting to give a product, if this is the rate constant, you find out that the rate law expression is going to be given as R equals K of 0 concentration of A raised to power 0. The 0 here indicates the independence in this particular expression. Hence, this is going to give us R is equals K of 0. Now, if we are to represent the rate as a function of the change in concentration, it is going to be given as a negative or decreased change in the concentration of the reactant divided by change in time. Having said this, the very next thing you are going to do to get the integrated rate equation is to equate these two expressions. R is equals this and R is equals this. So when we equate this to this, what we're going to get is negative change in the concentration of A all over change in time would be equals K of 0. Mind you, we are going to have to bring the variables or similar variables to the same side. So let's take dt to this other side. So we are going to have negative change in the concentration of A equals K of 0 dt. Now it's also important to take away this minus. It will make our solving actually easier. So when you convert this to a plus, this other side becomes a minus. So let's continue. Having said this, remember, integrated rate equation implies that you're going to be in an integration. So we're going to be integrating this particular guy for a given set of limits of initial and final, and also be integrating this particular guy too. Now if you do the integration of change in concentration of A, the integration of change in concentration of A would exactly give us the concentration of A for a given limit of the initial concentration and the final concentration. So let's use A of F here, okay? And then equating, if you integrate a constant, is going to still remain the same, so minus K of 0, but integrating the t is going to give us t for a given limit of initial and final value. So if we are to express this mathematically, we are going to have that this is the concentration of A final minus the concentration of A initial equals minus K of 0 bracket t final minus t initial. The initial time is 0, so we're going to put 0 here. This is now going to lead us to the formula A final minus concentration of A initial would now be equals minus K of 0 multiplied by t. So what do we do at this point? It's important you also take note that this formula can actually be rearranged to mean so many other things. Take for instance, if we decide to change or rearrange this such that we have a positive value for your minus k is converted to a positive value. If we decide to rearrange it, that means we are going to have to bring this guy over and this other guy is over. So that's going to give us A of 0 minus A of F equals positive K of 0 t. With this now, I would like to establish a particular factor. What factor do I need to establish? When you have a difference between your initial and final concentration for a particular rate or a particular reaction, that particular difference is what we call the change. It is also referred to as the amount of substance produced. It can also be said to be the amount of the reactant that has been converted to a product. Whichever way it is said to be, we are going to be representing it by the symbol X. So we'll have that X is equals K of 0 t. So with this, I presume you've learned that the integrated rate equation or the kinetic equation for a zero order reaction is going to be given by that change or the amount of substance converted to product equals the rate constant for the zero order reaction multiplied by time. I hope this has been helpful. Thank you very much for listening.